Given the graph of the polynomial function below, we want to determine the smallest possible degree, the left and right hand behavior, determine whether the degree of the polynomial is odd or even, determine whether the leading coefficient is positive or negative, determine the number of turning points, and then state the zeros as well as their multiplicity. Let's begin by analyzing the graph. Notice we have three x-intercepts, -4, 0, 1, 0, and 3, 0. We also have a y-intercept of 0, -1. Notice from left to right, the graph goes downhill, uphill, and then downhill. This indicates the function is decreasing, increasing, and then decreasing. Let's begin with g and state the zeros. The zeros are the x values for which y, the function value, is 0. This indicates the zeros are x equals -4, x equals 1, and x equals 3. Because the graph passes through the x-axis and does not flatten at all, each of the multiplicities is 1. For a quick review on multiplicity, if the graph passes through the x-axis at the 0, then the multiplicity is odd. If it passes through but flattens, the multiplicity is odd, but more than 1, for example, multiplicity 3, 5, 7, and so on. Here we have an example of a 0 that has multiplicity of 3. If the graph is tangent to the x-axis, or touches the x-axis and bounces back at the 0, then the multiplicity is even. Here's an example of multiplicity 2. If the graph is tangent to the x-axis, or touches the x-axis and bounces back but flattens, the degree is even, but more than 2. Here's an example of multiplicity 4. So again, each of the zeros here have multiplicity 1. The sum of the multiplicities, which in this case is 3, is the smallest possible degree. It could be more than 3 because we could have complex zeros that don't appear as x-intercepts. And now let's determine the left and right hand behavior. The left hand behavior is, as x approaches -infinity, what is y or f of x approaching? As x approaches -infinity, we can think of moving left along the graph. As we move to the left, notice the graph goes up, indicating the y values or function values increase without bound and approach positive infinity. The left-hand behavior is, as x approaches -infinity, y approaches infinity, or positive infinity. The right-hand behavior is, as x approaches positive infinity, what is y approaching? As x approaches positive infinity, we can think of moving right along the graph. As we move to the right, notice the graph goes down, indicating the y values or function values decrease without bound and approach -infinity. The right-hand behavior is, as x approaches infinity, y approaches -infinity. Because of the end behavior, we should be able to recognize the degree of the polynomial is going to be odd, and the leading coefficient will be negative. For a quick review on this, looking at the table on the left, for the left-hand behavior, if f of x approaches positive infinity, and for the right-hand behavior, if f of x approaches -infinity, then the degree is odd, and the leading coefficient a is negative or less than 0. So again, we now know the degree of the polynomial is odd, and the leading coefficient is negative. And then finally, we want to determine the number of turning points. Turning points occur where the function changes from increasing to decreasing or decreasing to increasing. Going back to analyzing the graph, notice we have a turning point here where the function changes from decreasing to increasing. We have another turning point here where the function changes from increasing to decreasing. Also notice the turning point on the left is the location of a relative minimum, and the turning point on the right is the location of a relative maximum. But to answer the question, the polynomial has 2 turning points. I hope you found this helpful.